Hello everyone, welcome you all. So today we have our very first guest on our podcast, and this is someone that I personally really look up to and I have extremely high regards for her. She's also my advisor and my mentor, and I'd like to introduce her by saying that first thing first, she has a 22-page long curriculum vitae, so she's really done a lot in her life, and she's here to tell us about her experience and how it all turned out for her today. And to introduce her, so she did her bachelor's in microbiology from Pennsylvania State University in 1986, and then she did her PhD from Harvard in 1992. And she did concentrate on virology during her PhD, and then she also completed her postdoc from the Wisconsin Madison College, and I think you graduated in 1995 from this place.
Correct, from the postdoc.
Right. Ever since then, she's been a professor at Wright State University and she has a tenure now. And she's also been the program director of biological safety here. And now she's the program director of microbiology and immunology herself. So this is just like a very generic idea of who she is. I think I'll call in her and we'd probably get to know her better and how her entire journey was today. Welcoming my first guest, and I'm very excited to have you on my show, Dr. Dawn Patricia Woolley. Welcome to my show.
Thank you. I'm glad to be here.
So how was your day today?
Oh, my days are very hectic. So professors are busy with classes and meeting students, but I'm also faculty president.
Mm-hmm.
So we have a Senate, and I'm new to that. I was the vice president last year, but being president, there's more to do. So there's a lot of meetings and a lot of emails. It seems like a lot of business is conducted by email. So that's keeping me busier than ever. But it's exciting to be president. So
sure, that makes sense. Let's start let's go back to your microbiology bachelor's and your Harvard days. And I'd like to start with asking you, what made you realize that you want to work with SIV virus? And how did you know that this is what you wanted to do in your PhD? And were you open to anything else, or was it many incidents that took you here, or how was your trajectory on this?
right. Thank you for asking that. So we'll have to go back a little bit farther. Before college into high school.
Okay.
My mother was very interested in medicine herself and wanted to be a nurse,
Okay.
but couldn't be because in those days they didn't have the money to send her to school. So she ended up working for a doctor for a couple of years, bringing patients back to the rooms and things like that, helping the doctor. And then she became a housewife after she had children, which was common in those days.
Right.
So I do think she regretted not being able to pursue a career in medicine. So I believe she steered me in that direction all along the way.
Okay.
So she taught me how to read before I was even in kindergarten, which was amazing.
Yeah, that is
So
amazing.
that put me ahead of the curve there.
Mm-hmm.
It really became serious when I got into high school because my grades were very good and my mother pushed me to get good grades.
Right.
And so I studied a lot. I wasn't the type of high school student that was partying all the time, but I did extracurricular activities. I did play in the band. I loved to play the clarinet, and I played basketball because I'm tall.
Definitely.
And did some track, some running. So it's good to be well-rounded.
Mm-hmm.
So I did study a lot. Part of the way through, I got a job. So I worked in a restaurant for some money.
Okay.
And so that kept me really busy.
Mm-hmm.
But throughout high school, my grades were really good, and so I thought I had a chance to be number one.
Right.
So I ended up being the valedictorian of my class.
Okay.
But this was at a time when there was only one valedictorian.
Wow. That's
In
amazing.
today's schools, you'll see 20 different valedictorians.
Right.
And so we graded not on an ABC scale, but like 90, 95, 100. So whatever your grade was, that's what you got. So it was easier to separate people out.
Okay.
But along the way, my mother steering me basically into the science type courses. So I did take a liking to science and I was in some advanced courses and also like calculus and some of the biology courses. So when we were looking at careers and such, different colleges, I started reading up in books and this medical technology career came up. And that sounded really interesting to be a med tech. A med tech is someone, for example, who works in a hospital in the lab, and a patient's blood sample goes down there and they test it for what microorganisms might be in there.
Mm-hmm.
So I did set out with that in mind. I looked at schools in the area. I did not want to stay in New Jersey where I was born. I wanted to get away. But the
We all do.
Pennsylvania State University had a very excellent microbiology program.
Mm.
So that drew me there, and that campus is located in the middle of Pennsylvania. No
Mm-hmm.
big cities. I don't really like big cities. So I liked the physical environment. They had a great program, and it was a big school, so that's a little bit scary. So I went into the microbiology program at Penn State, and in the first couple of years, you take your general courses.
Mm-hmm.
About halfway through, I joined the honors program. Again, my grades were good, and that placed me into a research lab.
Okay.
And I worked with Dr. Richard Frisk, and he worked on polyomavirus. These are DNA tumor viruses.
Okay.
And that piqued my interest because there was a lot of cancer in our family.
Mm.
So I really wanted to study cancer.
Mm.
But then I found out that viruses cause cancer.
That's interesting.
So that was new to me. That was new to everyone at the time.
Right.
They hadn't been studied that long. So
Mm-hmm.
I ended up working on what's called a BK virus.
Okay.
Those are initials, B as in boy, BK. And I did a project for 2 years.
Okay.
And I learned a lot. I was paired up with graduate students. And at the end, I wrote a thesis
Mm-hmm.
that's almost pretty much equivalent to a master's thesis here.
Mm.
But what steered me that way was the research. So I was in the med tech program.
Mm-hmm.
And if I'd have stayed in that program, I would have done a third year and then an internship.
Mm.
But seeing that I liked research, I left the med tech track and decided I want to be a researcher.
Mm.
And I just stayed for the 4 years and got the full microbiology degree. And so with this interest that I had in cancer, I was looking around at different schools, and I applied to, a bunch, half dozen or more. And Harvard was included. I thought it was a long shot. I had good grades.
Yeah.
So I
definitely.
was the valedictorian in high school, but I was also had like a 3.9
Mm-hmm.
summa cum laude, and with honors at Penn State. So that gave me a good chance.
Mm-hmm.
And I also had applied for a fellowship that would pay the first 3 years of Harvard.
Okay.
And it was from the Office of Naval Research.
Okay.
But I was never in the Navy. I didn't have to go into the Navy.
Mm.
But they sponsored these fellowships on genetic engineering.
Okay.
And I got that. So
Okay.
then I was accepted into Harvard. And specifically, I had applied to the Harvard School of Public Health
Mm-hmm.
because they had a cancer biology department. So when I got there, I had identified a professor that I wanted to work with, and he was working with feline leukemia virus.
Okay.
But at the same time, HIV came along, HIV/AIDS. And they started using that feline leukemia virus as a model system, and it wasn't the best model.
Mm-hmm.
And then that professor decided to leave and go to Stanford.
Mm.
And I didn't want to leave Harvard. I liked Harvard.
Yeah.
And so I searched out for another advisor.
Mm.
I worked in a herpes virus lab, Epstein-Barr virus specifically. But then I found out about another professor who was working 30 miles west of Boston.
Okay.
He was working inland, not right there at the coast where
Mhm.
Harvard is. There was a primate center. So it was called the Monkey Farm.
Oh. Okay.
And so they were working on the monkey AIDS virus. That was also recently discovered.
Mm.
And so that really piqued my attention. Again, steering away from cancer, now more into the AIDS area.
Mm.
But I took a liking to that, and I thought this is a new epidemic, pandemic. We want to solve the problem. So that was very exciting as a young person, to be on the ground floor
Mm.
of a new discovery.
Mm.
So I did end up completing my dissertation with that professor, Ron DeRosia, and that took about 5 years because
Mm.
when I switched from the School of Public Health, I had to actually reapply to Harvard,
Okay.
and I reapplied and got into the medical school.
Oh. Okay.
And I lost about a year because I had to take some additional classes.
Okay.
So I not only got into Harvard once, I got in twice.
Wow.
So yeah, that's a little different, right? So when I was there, I was given a project to look at how the virus mutates. How fast does it change? Because that's going to impact vaccines and all kinds of things. So that's what my project was on in the first half. And then once we came up with a mutation rate, in the second part, I was looking at whether these mutants or variants, like we have with COVID, were escaping the immune system. And they, in fact, were. So we infected this monkey with a molecular clone, did sampling along the way, took plasma, froze it down, and then we tested the viruses against the plasma along the way.
Okay.
So the virus would mutate, and then the monkey's plasma wouldn't neutralize. So it was an ongoing thing. So then the monkey had to mount a new immune response against the new variant. So it was just kind of like a war back and forth. So those were the two big phases of my project. And then I applied. Once you finish your PhD, you want to do a postdoctoral fellowship. So I wrote to different labs.
Okay.
And so I wasn't responding to ads. I was seeking out professors who I wanted to work with. And one of them was Howard Temin at the University of Wisconsin in Madison. And he was one of the three that won the Nobel Prize for discovering reverse transcriptase. So he was really famous. And he was working on this area of mutation and recombination of viruses that I was interested in. He wasn't working on the HIV virus. He was working on avian retrovirus. So I think he was interested in my background because I was already looking at mutations. And so I went there, and my project was on an avian retrovirus, looking at specific hotspots for mutation and recombination. And what was sad was that I was only there about 2 months, and this professor developed cancer himself.
Oh.
And he was not old.
Okay.
He was only in his late 50s. He was very healthy.
Okay.
But cancer can happen to anyone. And so he had to go under chemo and all of that. But I was able to complete my project with him before he died. And he did die while I was in that lab, but we published a paper together. And they gave us some different advisors. And so I stayed there for another 2 years to try to complete the rest of my project. And then I started applying to different universities. And I was specifically looking for microbiology departments and medical schools. And an opening came up at Wright State. And I also was trying to geographically get near Pennsylvania because my husband at the time, his family was in Pennsylvania, and we thought we could drive there and visit them. So I was trying to get something close to Pennsylvania, and I like Pennsylvania from when I was in school there. So this opening came up, and you know, it's not easy to get a tenure track position because there's not so many of them.
True.
So it had all the attributes that I wanted, and it's not a big city here, so I liked the fact that it was not.
Okay.
Yeah, because I didn't like those city life, and so it had everything that I wanted. And they also built a biosafety level 3 lab here, specifically to study AIDS, and so that was going to be my lab. And so it was, and I've been here since 1995.
Yeah, I saw that.
And you know, pushing now the 30-year career. So
Yes, that's quite.
so that's, and then once I landed here, I continued on some of the projects I brought with me because my professor had died and that lab was shutting down. But then I wanted to get away from the avian retroviruses. I wanted to study the real thing, HIV. So I went back to HIV, and we made vectors and continued to study some mutation recombination issues. And then I sort of broadened out into some other viruses and vectors. So I've worked with vaccinia virus, which is a pox virus, adenovirus, adeno-associated virus. And I'm not working with them specifically to deliver genes. I'm working with them more to study mechanisms. Although the one last project that I did a collaboration on with the adeno-associated virus, that could have become a gene therapy. That was getting closer to actually putting something into people. But more, I like to study more the mechanisms of the viruses, not necessarily for gene therapy.
Right.
Yes. And so along the way, then I had this biosafety level 3 lab, and I certainly don't want to get infected with HIV/AIDS, but I have all these young students working with me now, and I want to protect them. So I was always very conscious of biosafety,
Okay.
but I went deeper into that and studied and became certified in biosafety. I had to pass, it's like a 4-hour test. It was really hard. I'm a professor. I'm used to giving the exams, and here I am taking the exam.
Yeah.
And I did pass the first time,
Okay.
and that opened up some other doors for me. So I've gone to conferences, talked about biosafety, talked specifically about viral vectors, because they're very hard to assess the risk of those, because you're creating something new every time. So I give short courses around the country to biosafety officers so that they can understand how these viral vector systems. So that's how I got to be where I'm at now, teaching the courses like gene therapy, virology, biosafety. And some of the recent projects, we've been looking at the SARS-CoV-2, cause of COVID, and looking at the sequences. And we developed the mathematical formula for calculating random mutations, and we're looking at whether they're under positive selection, and then digging deeper into the mutations that we see, what they might be doing.
Wow, that was amazing to hear, and I honestly have so many questions from everything that you said at this point. But I think we wouldn't have that much time to get into the detail of everything.
Sure.
But let's try to cover as much as possible.
Okay.
So I think one of the things that you mentioned was your professor being affected by cancer, even though he wasn't very old. So do you think working in a lab and with his project could be one of the reasons why it happened, or was there any...
That's an excellent question. Actually, we wondered the same thing.
Right.
Because he went to that university at a time when they were specifically studying cancer.
Right.
That whole building he worked in was a cancer building.
Right.
And he was working with cancer-causing viruses. And they also had a lot of cancer-causing chemicals in the building. And so there were some other professors that got cancer in that building. Okay. And in that day, they didn't have biological safety cabinets. They tended not to wear gloves all the time. So being he was so healthy and he never smoked, he ended up getting lung cancer even though he didn't smoke. And he could have been exposed to chemicals and even cancer-causing viruses along the way because they didn't have the knowledge back then to protect themselves as we do now.
True. Do you have any other instances where the professors or people who are working at the research lab were affected only because of the kind of research that they're doing with anyone else that you know?
Well, I did hear, again, there were other professors in that building, but I don't personally know of any myself. There was one incident that came out of Chicago where someone got an acquired infection. They were working... in their case, it was, I'm trying to remember the bacteria. It was a bacterial infection that he got, and he actually died of it because he got exposed. So that was, I did not know that individual, but he had some health conditions that even he was not aware of that made it so that that attenuated bacterial strain actually cause disease when it might not have an otherwise healthy person. So
I think I've heard you talk about this in class once, that he died of it, Yeah, well, I think it's more reasons to take biosafety class.
Exactly, yes.
I think there was one more question. It's kind of related to what you said, but I also had this on my list of questions that I wanted to ask you. So you did say that you were one of those kinds that didn't happen to party and you just happened to study, and you were one of the people who always happened to be on first. So my question to you is, did it come to you at any cost? Like, did you have to sacrifice a lot of things to get there, or was it like it just happened?
No, I sacrificed a lot. So starting in high school, wanting to be valedictorian. Again, I missed out on some of the fun things that other students were doing. Again, I had some activities like the band and such, and I had fun doing those. But I felt like I missed out, looking back, that I missed out on some of the the more fun activities.
Yeah.
And then the same in college, really. So I went to Penn State. They're really big into football, the Nittany Lions. My mother insisted I buy a season pass to the football. I went to the first game, but the games there take the entire weekend.
Okay.
It's a big party. There's a tailgating party,
Okay.
and there's hundreds of thousands of people, and
Okay.
it's big.
Okay.
And as studious as I was like, I can't afford to have these weekends taken off when I could be studying. So throughout my Penn State years, I did a few fun things, but I was working very hard. And then once I got into the research lab, I would get up at 4 a.m. and go in and do an experiment before my 9 o'clock class just to be able to get it done.
Wow.
So I did sacrifice fun, I would say, for gaining, the position that I have now. And, personally, I did get married in graduate school,
Okay.
but I did not have any children. I didn't think I could manage graduating from Harvard and being in the lab 12 hours a day with having children at that time.
Right. That makes sense.
And so in later here, I've remarried. My first husband and I split up, but I remarried. And my second husband and I just did not have any children. We were then getting older, and there were other issues. So you do need to do that kind of thing when you're young, but it is very difficult to balance children with such a high demand career, and
Very
especially Harvard's so competitive. So that was definitely a sacrifice that I would say. And I think it's a little bit better today for women that they also recognize that like husbands can take off leave and help. There's paternity leave, and there's more, opportunities for that. Because if it's just you and you're trying to finish your degree, it's very difficult.
True.
Yeah.
Completely agree on that. If you were to go back and say, if you what would you advise the generation now? Would you say that you'd want to go back and have some more fun, maybe, or would you say no, it's perfectly fine for what you did? How do you advise the younger generation to kind of manage balance the fun and studying part of it? Because it gets really hard with 100 other things as a student, like everything managing by yourself, and you're still learning life. So it can get really hard to know how to balance it all.
Yes. Well, these careers are very demanding. So if you're going to go into becoming a PhD or even a medical doctor, you're going to have to work a lot of hours.
True.
And so you're not going to have huge blocks of time for these fun activities, but you can do things like exercising and maybe have some friends and have meals with them and go to a movie and things like that. But you do have to put in a lot of hours if you want to get that career. I think some students don't realize how much time you have to put in to get the research degrees. We have some in the master's program. They don't even realize that just for the master's degree, if you're doing a thesis, that you have to put in many, many hours, blocks of time. I mean, I would go into the lab sometimes in the wee hours just to get an experiment started before the sun was even up. And I mean, 12-hour days. So it doesn't leave a lot of time. But maybe taking some vacations here and there to get away. We would do that, sometimes go home and see family. But, of course, as a student, you don't have a lot of money either. So this is actually good. There's no money to really do the fun stuff.
True.
I can't afford a vacation other than going to see family, so I might as well just work all the time and advance my career. So now that I have a career, I mean, professors aren't necessarily rich, but it's a decent salary. And now I have that amount of comfort that I can buy things I need. I don't have to worry as much about money. So I have a more comfortable life. So now looking back, it was worth it because I see other people who have difficulty with jobs and they get laid off or they don't have a job and struggling. So my job is fairly secure, being a professor with tenure. And so it's one of the more secure positions that you can get.
Thanks for that answer, Dr. Woolley. My next question will be a little about, again, what you said. So what I wanted to ask you is, you spoke about the finances. Like professors are not, they're not. Even I personally feel that they're not paid as much as someone in the industry would be paid, while they're actually working harder and they're putting in way more efforts than someone at an industry would be doing. Do you think down the lane that would change, or is there something you can do to change it? Or
I think it'll always be that way. Professors, they do what they do because they love it. They love the research. They love students. So, yes, if pharmaceutical companies might pay more money, but there's some, like there's pros and cons. So with pharmaceutical companies, they might lay off workers. They might close a project, and you have to move around more. So it's not as much job security.
true.
You have to be willing to move and move your family if you have one. Medical doctors, that's another challenge. They make more money, but in my case, I thought I wanted to be the one behind the scenes finding the cure than administering the cure.
I pretty much relate to what you're saying.
Yeah. So, I could have went to medical school with my grades. And so it's not that I don't like people or working with people, but I just really love the research, and that's what makes the professors keep going and put in the extra hours. When I was in graduate school, I got a stipend, paid me for some living expenses. And I loved the research so much that I said I couldn't believe they're paying me to do this, because it was like they're paying me to have fun. That's how much researchers like the research.
Yeah.
Yeah.
I think I can understand very closely what you're saying. And then would you want to, I think you did talk a lot about your research and everything. You did sum it up for us, but would you want to talk a little bit more about how your Harvard days was? Because I can't.
How it was at Harvard?
Yeah, because for me personally, to be a part of Harvard is a very big thing.
Right.
And I can't believe I'm sitting in front of someone
Right.
who's gone there twice now that I know that.
Yep.
So
yep.
a little bit more about that.
Okay, yeah. So when I first went there, it's a big city. So for one, it's really scary. I'm in this big city. You think Harvard is not this small, quaint little campus. It's all mixed in with the city.
Okay.
So the medical school's in Boston, and the rest of Harvard is in Cambridge.
Yeah.
So just going there and having to adapt to living in a big city was difficult. But then you're surrounded by all of these really smart people. There are Nobel laureates there,
Okay.
National Academy Medicine members, really high up in their field. And so it's very exciting to be learning from them, but scary too,
I can imagine.
But I was always very challenged. That's what really excited me. You're around so many smart people, they're always intellectually challenging you. So I never got bored, and that made it really exciting. But getting the PhD, about halfway through, you have to take oral exams.
Okay.
So you have to write a proposal and defend it in front of a committee. And the committee that I had an expert in influenza. I was proposing to, I was hypothesizing that two proteins were close together in the virus structure. That hadn't been proven. And I was pushed into that by one of the other professors. They wanted to push me into an area where I hadn't really worked on proteins before. I was more nucleic acid person. But I think he pushed me into proteins because he forced me to then have to learn that and then defend it. So I did a hypothesis and laid out experiments, and then I had to get up in front of these people and present it, and they're grilling me on questions. So I'm standing in front of someone who did the crystal structure of influenza, asking me about the structure. So that was the scariest part.
I can imagine.
Was passing that preliminary exam. They call them preliminary exams or oral exams. They literally grill you. So it's like a hazing,
Okay.
But after I passed that, then you feel like, wow, I really did something.
Something, yeah.
Because passing at the end is also difficult. You have to get your experiments to work. You have to repeat things that don't turn out right. But by the time you get to the very end of the dissertation, you're more guaranteed to graduate. But if you don't pass the preliminary exams, you're out.
Oh.
Maybe with a master's, maybe a terminal master's degree, but you don't get the PhD. You do not go on if you don't pass that.
Oh my God, that's scary.
So, being there, it was a little bit, like I said, intimidating, scary, not just from being around such smart, famous people, but adapting to that city life that I wasn't used to. But I just loved the challenge that I got there from all of them.
Wow, that was incredible. I mean, I'm getting to know so much that I've never known before. So let's say there's somebody let's say our audience are watching this and there's someone who wants to get into Harvard. Any piece of advice you have for them to do something right now?
Yes. So the fact that I worked in a lab for 2 years at Penn State, that's really helped because I mastered some of those techniques. I could walk right in the door at Harvard and already be working in the lab. So you really are going to have top grades.
Okay.
They want the best people. That's what Harvard wants. You're going to, if it's a lab type of a situation, you got to have lab experience. I mean, there are other disciplines, other fields of study, but still there's other forms of research in those other examples, like history, for example. You might do history research. But I did physical lab-based research. So, and then your personal statement needs to be really solid. It needs to catch their attention because they're reading so many applications.
Right.
So you have to stand out and be different. And then I think doing other activities to show you're well-rounded. Maybe things related to medicine, possibly. Medical students that want to be medical doctors, they'll shadow doctors and just to show interest. So they're going to want that well-rounded person also.
I think, but it gets really challenging to manage everything while you're in, say, your undergrad or your graduate, managing lab, a part-time job, and studying for your college, and probably living, or if you're living in an apartment, like do your things by yourself, like you're cooking and cleaning.
Right.
So it does get very challenging to be everything what colleges are looking for.
That's true. That's true. I think today's generations get a little bit distracted by things, though.
Very true.
In my day, I lived in the dormitory for the first 3 years and then in an apartment, but my own. It was just a one-room apartment, no roommate.
Okay.
So in the first 3 years, we did not have, well, first of all, there were no cell phones.
Okay. That does give you a lot of time, I suppose.
There was no internet. We did not have a TV in the room, just maybe a radio. So we didn't have the distractions, so we could focus better. And that's what I think is a challenge for today's young people.
Yeah.
Is you're pulled in a lot of different directions. I did not have a part-time job at Penn State. I worked all summer long in the restaurant, saved up my money, and then I had a combination of a scholarship and a Pell Grant, because my family did not make a lot of money, and then a loan. And that loan, I was able to defer it all throughout my school. But when I came here to Wright State as a professor, I started paying it back, and it took me to age 40 to pay that back.
Oh, my God. Okay.
But it was worth it to get the education. Yeah, so, I just think staying focused is, you can have all of these things that you need to do in life, but if you keep that mental focus on your goal, you have to keep going toward that. And just let the other things happen around you, but don't let them pull you in too many directions. And you do have to watch your time. You can't overly commit to different things, and then you have too many things on your plate. So you do have to watch. You have to pick and choose what you're going to do.
Wow. Okay. I think there's this one question I want to ask you. I think you know what I'm trying to tell you here. We spoke about your pet very recently. So I want you to talk a little bit about that for my audience because I find it very interesting.
My seahorses?
Yeah, I'm talking about that.
Yeah. So recently, we set up an aquarium.
Okay.
And we started out actually, saying we're going to have coral, we're going to have a reef type of an aquarium, saltwater, and we didn't do very well with the coral.
Okay.
We bought a cylindrical tank that's tall, and not knowing at the time we were going to end up with seahorses. So the coral wasn't doing so well, and I don't think that type of a tank was the best for coral, and we got some fish, and we weren't doing so well with fish either. But we decided that these seahorses were very fascinating to watch, and they're like people. I mean, they have personalities. They'll come up, they'll swim up to the glass and look at you.
Yeah.
And when they interact with each other, they're all different, right? So we were just fascinated with them. And they're very difficult to maintain because they have a primitive immune system and a primitive digestive system. So they're prone to infections. Even if you keep the water clean, they can get them. And they have to eat constantly. And, you know, they swim around and they latch onto things with their tail. And they don't look back. Their tail just knows where to go.
Yeah.
You know, and they pair up. So a male and a female will pair up and bond kind of for life. And it's interesting that in that species, the males carry the babies. So it's totally opposite, and I think that's so cool.
Yeah.
You know, and so we've been doing this since January, so we're going on a year. We lost a couple. One got an infection, and one never really thrived. So they're shipping these in from places. So the first, 4 that we got were from Maryland, so it's within the continental United States here, and they have to ship them overnight in a box. So of those, we lost one right away, maybe just didn't make the transition, and then later the other one got an infection. Well, then that lady wasn't selling them anymore, and we couldn't find seahorses. So I found a place in Hawaii, and this guy has a seahorse farm. He's the world expert in seahorses. So we bought a male, and he did well. And then we realized that we really just, as we lost fish, we didn't replace them, and we wanted to go seahorse only. So we just got 3 more seahorses, 2 females and a male, so that could enable them to pair up.
Okay.
So if they wanted to, if they like each other.
Have they already paired up now that they're very new?
The 3 new ones are 4 to 6 months old, so they're considered juveniles.
Okay.
So they might need to mature a little bit more.
Okay.
But we're hoping that they do.
Yeah, please let me know.
We want to see seahorse babies.
Yes, please let me know
I
if
will.
they do pair up. Is there anything that you're working in a lab right now? Like any research that you're doing currently?
So, again, I mentioned earlier that I'm interested in looking at the genetic sequences of the SARS-CoV-2 virus, and in particular the spike protein, looking at mutations. And I developed this formula that I would like to pair up maybe with a computer programmer so that we could plug in numbers and not have to hand calculate, because that takes a lot of time.
Yeah, I know.
So I think right now I'm just mostly interested in looking at those sequences.
Okay.
And I'm also interested in as far as biosafety goes, viral vector safety. I've done a project on looking at when we're infecting these animals with viral vectors for research. We look at how much comes out of the animal, where's it going in their body, because from a containment standpoint, if you're going to infect animals, you have to contain them and protect the workers also from that. And then that kind of translates to gene therapy, because we now treat patients with these viral vectors and send them home to their families. So we don't want that spreading to their families. So this issue of shedding particles is of interest to me from a biosafety standpoint. So I do some biosafety research also, which is sometimes some people might think that's more boring, you know, but it's important to do. Yep.
I think I've covered most of what I wanted to ask you, but there's still a couple of questions. And one of that is, so I think, would you like to talk something about being a director and representing Right State and how far we've come, considering you've been working for 30 years now? So is there something that you'd want to talk for a university?
Sure. So, I was the director of the biosafety level 3 lab for a long time, and that was a lot of responsibility. But I think what you're talking about is this master's program that I took over the directorship of that in 2018. Is that what you were talking about?
No, you're open to talk about anything as a university or a director yourself. So maybe in comparison to how we're doing from where we started, and to just check on how other colleges are doing in immunology, microbiology, and where we stand in particular, just for our audience.
Yeah, sure. So I've been here for 30 years. I've seen a lot of changes. I've seen changes in the medical school. My position is 60% in the medical school.
Okay.
So we've actually changed how we teach medical students. We used to just lecture to them, and now they do peer teaching.
Oh.
So it's more interactive, and I think that I'm also seeing that amongst the undergrads and the graduates. So instead of just lecture, we're trying to do some more interactive classes, because this is adult learning. Adults learn different than children, so they like to do things and hands-on. So there's a trend towards that type of learning, and there's also a trend towards merging things together. So when I came here, we had a microbiology department, an anatomy department, a physiology department. And they were small, but we had experts in all of those things. And the reason we did is because each of those departments would teach the medical students. Microbiology taught microbiology. And when the medical curriculum changed, they were teaching these courses by committee, no longer by department. So they started merging the departments together. And I'm seeing this at other universities. So there's a tendency now to create larger interdisciplinary departments. And I think science overall has gotten more interdisciplinary. We don't just stay in our little cubby holes anymore, like the microbiologists. We're doing some of the same techniques. Like just about everybody does PCR. So there's some universal techniques. And I think that scientists really like to work together, and they always have. But things are more collaborative than ever. So I think that the interdisciplinary creation here, we're about to do that with some of our master's programs, is merge them under an umbrella and be more interdisciplinary. So as far as the big landscape goes, there are some less children going to high school kids coming to college now. I don't know if you've heard about that.
No,
but there's a demographic issue in the U.S.
Okay.
where there's just simply not the numbers of students that are entering college, and they're worried about having debt.
Oh.
Like I told you, I had a loan. So some of them are hesitant to go to college, but the birth rates are down in this country, so there's just not as many of them, and then some of them are choosing not to go to college.
Okay.
And the pandemic sort of disrupted things, so enrollments went down at colleges, and people are rethinking what they want to do, and maybe going into trade schools instead of college. But there are some careers that you have to go to college. You want to be a doctor or a lawyer. So, a certain amount. And so we're also taking some of our programs, and some of the other schools are doing it, and we're creating efficiencies between different programs where there's some overlap. And we're just updating everything. We're teaching more what students want to learn about. So the subjects are changing a little bit. We're redesigning our courses to be more modern, to address things that are happening in the world now. I think everybody's doing that, and we're also doing that.
Yeah. I think from where I come, I'm originally from India. From where I come, it's a hustle. Everybody applies to colleges. Everybody wants to get in. Everybody wants to be at the top. So it's a completely different situation.
It is very different. It's interesting that we have those two perspectives. But
True.
And that's one of the reasons we do have a lot of international students here.
Yes.
It's because the U.S. students aren't going to school. So
Yeah.
I mean, some of them do, but we do have a lot of international students for that reason.
True. This is a little off the track, but feel free to go ahead and answer it in case you are comfortable. So I do have a lot of medical friends, people who are studying. Medical is a little bit different in India. I have a lot of cousins and friends who are studying medical. So considering you've actually done so much change in this field in US, is there something that you would want my audience to take away? Maybe not from an exam point of view, but something they can do to be at top, to grow, and to just know what's happening in the world around, and to just have that passion to be a doctor and to like learn it all. And any way they can change the way they study, or something they can do to, or just have a small not a comparison, or maybe just how things work in US and how this can be applied to my home country.
Yes. So you have doctors that get in your country.
Mm-hmm.
Right, you can get a bachelor's degree, and that can be in medicine.
Mm.
So is that an MD in your country?
No.
You have to go further.
Yeah. So a bachelor's degree would be for 5.5 years, ideally 5.5 years. So in that, the final year you would be doing an internship. So wherein actually working with in the hospital, treating a lot of patients. And from where I come, which is from the South India, Bangalore, most of the hospitals that I know have a lot of patient intakes. Like every day, it's especially government hospitals, the number of patients and the number of diseases you see. I think we were talking about tuberculosis also recently. So the number of people having that come to a doctor to see you for different things are really high. From what I have seen here, it's really high. I haven't seen a lot around here, but yeah, from what I've seen in India, it's very high. So you get a good amount of experience in the field when you're interning, but that does give you a medical degree, but not an MD. So again, if you want to be a surgeon or pursue your career more, you have to do an MD or an MS, which is again very hard to get in, extremely competitive. And it also, even though you get a seat based on merit, it is very expensive. Not maybe compared to the US, but for someone who lives in India and who earns in India, it does get very expensive.
Yes. Well, I had a student from India who entered my master's program here, and she was an MD.
Oh, okay.
She was an MD, and she wanted to get her fellowship or her internship here. And so she had to pass the board exams here. So she studied for those.
Okay.
And did very well and got her position. And that's how she got into medicine in this country. But she was already a medical doctor.
Okay.
So she already had at least that degree. I think there really are a lot of parallels. Because if students know they want to be a doctor, you have to take certain courses and do really well. It's always a lot about the grades. But in this country, you have to take, the MCAT, standardized tests, and do really well. And you have to show them that you have an interest in medicine. So you try to do things like work with patients, volunteer at hospitals, nursing homes, to show that, and so you're well-rounded.
Okay.
And so they do look for those well-rounded candidates. So I think there's a lot of parallels, really, even though the educational system is different. You have to stay focused and be dedicated and work really hard in both situations.
That is there I think every situation, that is the one thing that you have to do. So I think we'll be ending this session real quick. I have one last question for you, and that is for someone who is not from STEM at all and knows nothing about immunology, microbiology, like nothing at all. Is there something that you want to tell them from a safety point of perspective, or anything that you feel is necessary for someone to know from a non-STEM background and it's not really out there?
I think that, if you're from a humanities background or a liberal arts background, you still need to be aware of microbes in the world. I mean, we've just lived through a pandemic, and so you have to have some knowledge. When this mRNA vaccine came out, people didn't understand how it worked. So there is a certain level of understanding that you have to live in the world, even if you're not in science.
Right.
And as a teacher, I try to find ways to explain that to people that are not scientists. So I think just having an awareness of the microbial world and how amazing our immune system is to be able to respond to all these diverse organisms, it's an amazing piece of work right there, our bodies are, and how the immune system works, and the diversity that we see there.
So I think that's one of the things that I really concentrate on because I think at least today's generation we're so used to looking at people or ourselves with the color that we are or the shape we are and how much fat is there and anything about yourself, but it's not truly how much is my body actually doing for me. So I think truly that is something that people really have to know.
Yeah, I mean, the body is amazing how we fight off these infections, and we also fight off cancers.
True.
Every day, we can have cancer pop up in our body, and our immune system fights that off too. So it's doing all that work, and we don't even realize it.
All right, Dr. Woolley, this was really amazing, and I'm so glad I actually got to know so many more things, and I hope my audience too have a lot of takeaways from it. And hopefully, I'll see you soon again, maybe on some other things, and we'll probably get into something much more interesting. And thanks for coming, and have a great day.
Thank you. I enjoyed it very much.
Thank you so much.